Hello everybody. Today we'll do some problems on parallel sailing. In this question, latitude. So ship is somewhere here. Says steams due west. Now steaming due west or east means that you're sailing a longer latitude and the distance traveled or distance made good is the departure, or the departure is the distance, vice versa. So the departure made by the ship in the latitude this is 120 miles. Knowing the departure, I can always find out along with this formula what we have proved earlier. When he says that the ship goes due north means that you are sailing along a meridian. You are sailing along the meridian. And the distance traveled along the meridian is d lat, because d lat is arc of the meridian. So the distance traveled by it is d lat. Then it goes east again. It goes again east. Going east or west is always the distance traveled is your departure. He says, and is then again in the longitude where she started from. After sailing 100 miles east, it is back on the meridian it started from. Started from here, went like this, went and back to this. So what does this mean? That the D long made here is the same D long what was made here. So we know the D long, we know the departure, we can find out the latitude reached. It says leaves a place in this for a port on the same longitude but different latitude. So leaves from here for a port on the same longitude but different latitude. Then she sails east. Sailing east, as we just said, is your departure. Knowing my latitude, I can always find out the D long what she has made. Sail east. So the D long made by the ship when she sailed from her meridian initial position to come to this meridian here is 390.9. That's your D long here. Then she sails due north. Sailing due north along the meridian. And when she is sailing along the meridian, she is not changing her longitude. So whatever longitude is here will remain the longitude here also. So she will maintain her longitude. And she reaches the latitude of the port. How far is she from her destination? So how far is she from her destination? That is your Now they are on the same latitude. That means it's your east and west distance, and east and west distance is called the departure. So we got to find out a departure here. We know that by sailing north, she was sailing along the same meridian. As you can see, the two meridians are parallel to each other. So whatever D long is here will be the D long here also. And this D long is the same here. So we know the D long. We know the latitude arrived. We can find out our departure. And our departure is 235.2. That is her distance from her destination. This question's vessel sailed from this position when due north. This is the position. She is going due north. And due north means she is following her longitude. And whatever distance she is going to travel, that is also your D lat. So she left this position. She has gone due north 350 miles. So 350 miles is your D lat also, because that's the arc of the meridian. That is what your D lat is. So the distance covered is your D lat. We know what the latitude she left. We know the D lat. We can find out the latitude when she reached B. And she was going along the same meridian. So that means her longitude would be the same. This is your position when she reached B here. Then he says it goes west, 350 miles. Going west means what? Going along a parallel latitude, and that is your departure. Your departure is 350 miles. We know the latitude. We can always find out our D long. We know the longitude of B. We can always find out the longitude of C. So longitude left at B, D long west. We have arrived. Position C here. That is the longitude. And latitude would remain the same because she was running west. That was along the same latitude. So latitude arrived would be the same here and here. The longitude has changed. Now she goes south. Going south, as we said, is along the meridian. Going south along the meridian. And whatever distance she has covered would be D lat. And she has done 350. So your D lat would be 5 degrees 5 degrees 50 minutes. South in this case because she went south. So this is the latitude left. Now B from C here it is B on C is the same latitude. D lat is south. So you'll be back on the same latitude where you started from. So you are back on the same latitude where you started from. And then now she goes 350 degrees east. 350 degrees east, that is along a parallel of latitude, that is your distance. So we know our departure, we know our latitude. We can always find out the D long. The D long made with departure of 350 degrees in the latitude of 29 degrees 46 minutes. My D long is here. The longitude here 29 degrees. So longitude left at B, D long easterly, longitude arrived at F. That's my longitude arrived. Here he says a vessel is in south, steaming due north 175 miles. This is the position what she is leaving. Going due north, that's along the meridian. Whatever it is doing is your DLAT as well as your distance. So that's your DLAT. So we can find out our latitude arrived. Then she goes due west. Going due west, east or west to 290, 90 to 70. It means that you're sailing along a latitude. Whatever distance you have done is your departure. Knowing the departure, knowing the latitude, I can always find out my longitude. So this is my longitude arrived. So that's my position arrived. Now if this question was put to you, that instead of sailing like this, you should have gone west and then due north, you would be arriving at a different position, which you can calculate and figure it out yourself. Because here with this departure, the D long would be different. So ultimately you'll reach a different position. Says two ships. Ship is on equator and ship B is on northern latitude and it's on the meridian 5 degrees to the west. But being 5 degrees to the west means that is the belong between A and B. I says both the ships start moving at the same time. And A is moving at the speed of 15 knots. Now along the equator, whatever distance she is going to do, that is your departure as well as your D long as well as your distance. It says after 10 hours, the D long between them is 9 degrees. So A is going at 15 knots, would cover up 150 miles to the east, which is its departure, as well as the D long. So the D long made by A on the equator is 2 degrees 30 minutes. Whatever distance she has done along the equator, as we have talked about it, along the equator, the distance covered is your departure as well as your distance. If you remember by your formula, but departure by D long is equal to cos latitude, you can figure it out that departure is equal to D long at equator. Now I said the initial D long between them was 5 degrees. And after 10 hours, it is 9 degrees. So the total D long, what has been made in those 10 hours is 4 degrees. A makes a D long of 2 degrees 30 minutes. So the rest of the D long should have been made by B, which is 1 degree 30 minutes. Now B is also moving along the equator, going west, along the parallel of latitude. Going west means along a parallel of latitude. So that distance, whatever she is doing in 10 hours, that is at the speed of 7 knots, that will be 70 miles. That will be the departure made by ship B. You know the D long made by B. So we can always find out what is the latitude of. Now he says here, two ships leaving a position to reach a position. So one ship, I'm showing you two different diagrams here. They both are in the same position, and they both aim for the same port, same destination. Now he says the A steers west to 48th meridian. Now going west, when it is going west, that means she is sailing along a parallel of latitude. So she goes from A to the meridian of the port. So the distance what she is covering up is between the two longitudes, which is the D long. So we can get the D long between the two meridians here, going west along a parallel latitude, and the distance covered along this would be the departure. So on the parallel of 55 degrees, whatever distance she is doing, that's your departure, east and west distance. Now she sailed from point A to the meridian of the port. So that is the D long made by the ship here. And I know what latitude she is in. I can always find out my departure. So the departure made by A when she sailed along a parallel latitude west is the distance what she has covered to come to the meridian of the port here. And the distance is 227. So that's the distance what she has done when she has gone west. And then she goes north. Going north, that means along a parallel of latitude, whatever distance she is going to do, that will be the D lat. And she reaches up destination. So the distance covered when she is going north is your D lat. And the D lat between the two meridians, she left 55, reached 61 D lat. So that is the distance what she has done, 345. So the total distance what is being done by A would be 227 plus 345. Yeah, A plus B. Now he says B goes north first. So B, when going north, distance covered would be the D lat. Yeah. And the D lat 345. So B would go 345 north first. Then she goes west. She goes from here to here, west. So west means along a parallel latitude. So whatever distance she is going to do will be your departure. And it sailed along the meridian. So that means the D long, whatever was the D long between these two meridians here, is also the D long between the two meridians here, because the meridians are the same. So the D long made by B, 6 degrees 39 minutes. What was made by, what is the D long between this and this here? Is the same D long here. And we know the latitude. So we can always find out what is the departure made by B here on this latitude, which is 193. So the total distance moved by B, traversed by B, would be 193 plus 345, 538. Now the distance covered by A, distance covered by B. So distance of A is actually more by 34 miles. So B will reach its destination 3.4 hours earlier. Now these are some questions for you to solve. Solutions will follow. In the meantime, you guys can go through it. Thank you.